Hello everyone, I'm really excited to share another video with you because this has been a long time coming. On the front of this though, I want to advise you that this project is still kind of like a passion project and I was really excited to share it with you, but as with all passion projects, some things happen faster or slower than kind of we expect. There is a disadvantage to sharing something like this so early, is that there is an expectation that you all will be able to build one tomorrow and not have any issues. I want to advise that this is still a very early project. There is a decent amount of hacking needed to get this running, and then this is not drop-in compatible with the current Voron ecosystem. It may be in the future with some of you all have been reaching out to me and working on some of the problems that we need to solve in order to fit this in a standard Voron printer. But we're just not there right now. So if you all listen to this with that in mind, I'd really like to share some of the background of this project with you. So let's go over the design goals of this printer. This printer is really designed for one purpose, and that is to be able to 3D print parts that are designed for injection molding in ABS. And so there's a few things here. One is this build volume is very large. You'll see the build plate is 410 millimeters wide, 350 millimeters deep, and then the Z travel is 475 millimeters. So this is a very large printer. Due to that, I added some extra rigidity by making the whole essentially cube out of 40/40 extrusion with double slot. The nice thing about this is it fits the same, it's the same slot size as a typical 20/20 extrusion, so it's basically 4 20/20 extrusions put together. This does increase the cost significantly because if you think about each of these joints, there are 4 blind joints where you would typically only have a single one. And so if you multiply all the drilling and tapping that Masumi would have to do in order to make this frame, it quickly just blows up. And so what I did is I ended up purchasing all of these extrusions without tapping and drilling from Masumi, and I think it was around $250. If you look at getting Masumi to do all that, you're quickly looking in the $600+ range, which gets really kind of prohibitively expensive, at least in my opinion. This frame also, in addition to the rigidity, also gives me room to insulate the printer. You'll see around this perimeter here, there's a 20 millimeter gap from the outer edge of the printer itself that would be moving to the outer edge of the frame. And this will allow me to use Reflectix or insulation or an air gap or an outer panel, a lot of different solutions in order to get this temperature up in the chamber. And really the purpose of that is because, again, injection molded parts, as you may have listened to in other videos I've done, are very thin walled. And those thin walls means there's not a lot of surface area for one layer to adhere to the next one. That means that you have a lot of chance to warp and split, as well as just the part not to be very strong. So any chamber temperature you can get in this case is a huge deal because it gives you extra structural integrity. As far as the Z assembly, you'll see I basically replaced all of the parts that I had previously with the stock Voron Trident parts. And even with this large build plate that's half an inch thick and is 11 plus pounds once you add all the spring steel, magnets, and heater, this Z assembly is rock solid. So I don't have any concerns with it causing issues. I am also grateful that this Trident assembly has some room for the lead screw to kind of move side to side, because anytime you get lead screws that are this long, the chance for them to be slightly bent is just exponentially increased. So my lead screws aren't perfectly straight, but again, I don't think I'll have an issue because there is that additional adjustment. So I just keep these lock nuts down here loose so that we have some side-to-side play. Let's see here. So the next thing is really around IDEX versus a single nozzle multi-material solution. So I have tried again in the past with the Palette 2 Pro using ABS and hips. I was able to splice them together, but I got cross-contamination in the single nozzle. And those two materials ended up causing, since they don't adhere well to each other, ended up causing me to have layer adhesion issues where just the part straight out of the printer, no processing with laminine or anything like that, would just split apart in your hands. You barely put any force on it and the part would just break apart. So I knew I wanted to get to an IDEX solution or tool changer, but tool changer was a little bit outside of my kind of skill set, and this was the easiest solution. So I ended up picking up an IDEX belt path. One thing I haven't touched on is what I'm going to do for the door. And I haven't purchased the door because at the time I made the order for this printer, I didn't know what I was going to do. But now, since then, which has almost been a year, about 10 months since I ordered these parts, I've done something like this for my 350mm Trident. And this door is really just using off-the-shelf Misumi parts, including hinges, which are not shown here in this model. The one thing that's really slick is this flat front 2020 extrusion, which I think really kind of gives a professional look to the printer. As well as this door handle over here. It's an extruded aluminum handle that bolts to a piece of 2020 and kind of looks like a refrigerator door or something like that. It's not super expensive. You can get it cut to length. Again, I don't show the kind of caps here that cover the ends, but there's all these kind of off-the-shelf things that look really nice. I don't have a solution for the kind of latch yet. I might use some magnets, but I'm really excited about this door. You can fit kind of double polycarbonate panels up front to still give you that nice insulation, but be able to see into your printer. So this is probably what I'm going to do eventually for my Voron, the larger IDEX Voron, but I haven't bought the parts yet. Let's talk about kinematics for a bit now. So kinematics is for Core XY can be really easy or really confusing. Obviously, if you had a y-axis that moved up and down, and then two X motors mounted to that y-axis, that would be probably the simplest Cartesian-based system. However, that means you're moving two X motors as you're moving Y, so there's a lot of moving mass in the system. This is this belt path here listed on the Duet forum, which I believe is the Core XYU system. Is really trying to keep as much of the Core XY system intact, using the same A and B motors as we have today to control the position of one of the tool heads. But then the second tool head follows along on that y-axis, but then has a third motor with a T-shaped belt path here in order to control the X position for the second tool head. While this, there's definitely solutions that use this. Its advantage is it only needs 3 motors. The disadvantage in my mind is that you have, again, 4 belts crossing the X-axis. And packaging that can get kind of difficult, in my opinion, when I looked at it, because there's a lot going on in the X-axis of a Voron printer with cable chains and stepper motors and everything like that. And I really didn't want to go through all the pain of modifying all those parts if I could avoid it. So what I ended up looking at was actually trying to keep the existing Core XY system intact. And what I didn't realize is that it kind of matched this kinematics here with a different belt path. So what this kinematics is, which I believe is the Mark Forged kind of style, you have a single Y motor with a shaft to both sides, or else 2 Y motors traveling at the same speed and same position. Moves this y-axis forward and backward. And then you have 2 x-axis motors with T-shaped belt paths to move the X position for X1 and X2. Again, the advantage of this is, things are a little bit more balanced theoretically because you have, a Y belt on either side of the X-axis. However, the disadvantage with this, again, is still you have 4 belts crossing the X-axis, so there's a lot going on there. My intent, again, was to only use 2 belts across the X-axis if possible. So essentially what I ended up doing is converting this T-shaped belt into a P-shaped belt without even realizing what I was doing. Because if you look at a P-shaped belt like this, and then an inverted P-shape for the blue blue line here. You get 2 belts across the x-axis, and basically all of these B1 and B2 belt paths end up being exactly the same as a Core XY belt path. So that simplifies a lot of things because I can reuse the exact same parts for the Voron printers using the same belt paths for the tool heads, except instead of controlling X and Y for a single tool head, they're controlling X1 and X2 for both tool heads. So let's jump back over to the CAD here for a second to look at that. So the first thing, in order to use the same Core XY belts as essentially Core XX belts, you really have to allow the belt pass-through. So because essentially one of these belts controls the left tool head and the other belt controls the right tool head. And so instead of having the belt completely secured, you need the belt to pass through. And again, this was one of those gambles and one of those things I spent way too much time on trying to figure out what the best way to package this. And at the end, what I did was the quickest and easiest kind of minimum viable product approach, where I just cut a hole in the existing MGN12 kind of Trident X carriage. And you'll note that that essentially puts this belt flush against the X carriage, so it could slightly touch it as it's kind of passing by. And that may be a bad thing. And also if you kind of cut through here, let me just do a section analysis quick. When you get through to these screws here that are going from the X carriage into the MGN12, you see there's not a ton of clearance there for that belt. My hope was that it wouldn't be an issue. I haven't run into issues yet, but it might not be the most robust solution. Again, I wanted to test it out and see what the kinematics were like and address these problems as they come up in testing. So this model shows that the left tool head has the top belt passing through and also the right tool head with the top belt passing through. In reality, this one has a cutout on the bottom section. So each belt controls the X position for one of these tool heads. So now we've used the existing Core XY belts as Core X1, X2 belts to control the X position for both tool heads. However, that leaves our Y completely unconstrained. So we need to do something very similar to what the kinematics showed and have essentially 2 Y motors to control the Y or the X axis at both positions. So I found out that it is relatively easy to add those Y motors and Y belt paths directly underneath the existing 2 Core XY belt paths essentially. So the second Core XY belt is down here, and I just spaced a third belt the same distance down and added a small idler down here, which is again very kind of janky, but it works. And then I trimmed a little bit off of this this XY joint here to allow the same amount of clearance as we have with these other ones up here. And then over here, there is a small slot here with teeth that allow me to constrain that belt. So let's see if I can do a section analysis here to show you what it looks like. Essentially, the front side comes in here, grabs onto these teeth, and then this belt back here loops over and is constrained by these teeth. So we have a secured position in both areas. And in order to do that, I had to create a way to be able to insert the belts in there. So what I did is I created an additional split down here in this part so that the belt can be inserted from the bottom. So with a little bit of changes to the front idlers and the XY joints, we now have a place to mount the Y belt and the front idlers, and we just need to figure out where to stick the Y motors. And this is where things get a bit tricky. I made a decision early on with this design that I was interested in trying to put the motors behind the frame of the printer. And if I knew now what I know then, or if I knew then what I know now, I would probably not do that because I'd try to keep it a little bit more stock. I ended up squeezing the back of the frame up front a little bit more to take advantage of some of that extra space and make the enclosure smaller. That made this rear Z stepper mount more difficult. Yeah, so it wasn't all good in the end. But what I ended up doing is I ended up sticking all 4 of my motors out the back. And again, these parts are like super basic because I'm just trying to do a proof of concept. So I ended up putting the Y motors on just a very basic printed part with slots to be able to pull them back and then tighten them down with screws to tension this Y belt. And while it works, it's not that great. And so I'm probably going to change this in the future. So we'll see how it goes. The tricky part is that if you stick the same NEMA 17 motor, see how it overlaps with the vertical 4040. It would also overlap with the 2020 in a standard Voron printer. So in order to really package this, you either need to keep the Y motor behind the printer on a standard Voron printer, which means that you're going to need to redesign some things, and it doesn't really work on a V2, or else you need to package it in front of the vertical extrusion, which is a little bit tricky because then you end up losing some Y travel. So I am looking at some other solutions there, and I'll get to those in a minute. But first, I wanted to touch on the kind of the Core XX or the X1 and X2 belts. I essentially tried to keep this a very similar setup to kind of like a standard Core XY setup, where the belts loop around idlers and come back out the back. I really hate how they are kind of so far away from the from this back panel. They're just kind of floating in air. That just seems really bad to me and just doesn't seem very clean. So I'm not super happy with it. But again, trying to get something that prints, which as you've seen in my previous videos, it does. And we can optimize all this here in the future. So as of right now, it prints. We have our 4 belts, 2 that are the same or similar to a standard Core XY system, plus 2 Y belts. The nice thing about this, though, is that one of the biggest issues as you get to larger and larger Core XY systems is that your X-axis has a tendency to kind of rack or like become angled. And that's not great because that means your parts don't come out, perpendicular, and things just kind of end up being a bit funky. And you can adjust that by adjusting your tensions for your A belt versus your B belt. But the longer and longer your X-axis is, the more chance you're going to have issues. With this belt setup, though, we have 4 motors and we have 2 independent Y motors, Y1 and Y2. The nice thing about this, just ignoring the X-axis belts for a moment, is that we have the ability in Clipper and I'm sure other firmwares to have 2 Y end stops, one on this side and one on the other, that are tied to the corresponding stepper motors. And as I've shown in videos in the past, what this allows us to do is home Y to hit both X end stops so that even after powering off and powering back on, you'll make sure that your X-axis is square every time, which is really cool. I really like that feature, and I think it's really helpful as you build larger printers, which is also one of the requirements for an IDEX build, because you lose essentially twice your tool head width. And so these tool heads are around 60 millimeters wide, so this 410 millimeter X-axis width means that 410 minus 60 gives you, in the high 200 millimeter of usable printable area with both tool heads. So by nature, you're going to want a wider printer, and by nature, wider printers in Core XY systems generally have more issues. So this belt system basically mitigates those concerns, and the X-axis is super rigid. I just love it. It's really great. So having said all that, we're getting close to the end. So the question you all have been waiting for is, when can I build my own Voron IDEX printer? And there's a few things to that. So as I mentioned before, we really need to solve this issue with the Y steppers needing to fit inside the frame for a typical Voron printer, because if the belts have to go through the back panel for a V2 or a V1, it's really going to get complicated. So one of my current kind of fiddly plans has been to actually look at redoing the AB drives. And this model is again kind of proof of concept, but what I found is that with the existing space in front of that 2020 joint, if you take a NEMA 14 motor, similar to what we use in the V0.1, instead of a NEMA 17 motor, this distance here is about the same as a typical AB drive for a V2 or a Trident. So that's really exciting because you can package this without losing more than a few millimeters of wide travel. In the grand scheme of things, these V0.1 NEMA 14 motors are more than powerful enough for this condition. A lot of us use 0.9 degree stepper motors that actually have less torque and less speed capability than these 1.8 degree V0.1 NEMA 14s. In that same aspect, this is actually another NEMA 14 motor, so a duplicate motor, to drive the X1 and X2 belts. And theoretically, it's possible to stick a NEMA 17 back here. I haven't really seriously looked at either package. I just saw I was running out of space, and I didn't want to push this edge over into this area too much. So I was looking at 4 NEMA 14s essentially for the AB drives. So theoretically, in the future, this would be a solution that would allow us to fit all 4 belt paths within a Trident or V2 kind of printer without going outside of the printer and losing minimal travel. So this is still a work in progress. To my knowledge, no one has printed these parts or installed one in the printer, so there's a lot of work to do. And of course, all of this is very rough right now. So there's still a lot of work. So as far as the XY joints and the front idlers, the parts that I have right now are definite, and also the X carriage. The parts I have right now are functional and I think adequate for most people to use for initial testing. But if we go to a AB drive like this, there's no way to tension the Y belt using this Y motor sliding it back and forth because we're constrained. If we add any slots, then we will lose Y travel. So some people are looking at, can we add dual tensioners up here to not only tension the X1 and X2 belts, but also the Y belt? And that would be the most ideal solution because then again, you won't have to be reaching around the printer to try to access those parts. So assuming we get that worked out and the XY joints are functional and we get the AB motors worked out, from a physical printer standpoint, you could fit it in a Trident or V2. From a firmware side, there is a lot of work to do here. And by that I mean that if today, in this very moment, you had all this printer assembled, you would still need to pull some files from different pull requests and make essentially a custom version of Clipper in order to get all the different duplication modes and all those different IDEX kinematics functioning properly. So there's more work to do there. It'll make it a lot easier once those things are merged and developed to master in Clipper, because then essentially it'll be less of a hack job in order to get things working. And then also, this is still very early in development. There's still more work to be done, including like a wiper solution for the nozzles and that sort of thing. So it's exciting. I love this project. I'm really excited to potentially have a printer in the future that would allow people to, throw anything they want on their printer in any orientation and get it kind of like my upside down benchy. But there is a lot of work to do. And I know that I'm very busy at the moment, so I probably won't have the bandwidth to get this stuff out very quickly. But I will be getting this cat out to you guys so that if you want to fiddle around with it, tweak it, improve it, that would be fantastic, because I think as a community we can push this project along. So with that, it's been a lot of talking. Thanks for sticking around if you're still there, and we'll catch you next time. Thanks.